Alright guys, so we're going to do this lab where we're going to take water and heat it up, and we're going to see how the temperature changes as it moves from freezing all the way to boiling. So in order for you to predict some things, I need you to understand what temperature really is and what it's measuring. So you will be quizzed over this, so you do want to pay attention to this, but in physics, you should have learned that kinetic energy is energy of motion. So when an object is moving, it has kinetic energy, right? So if we were to kind of look at some examples of this just for fun. So let's say you have a big truck, right? And that big truck is driving down the road. I draw better on a whiteboard, but that truck is driving down the road at 20 miles per hour, right? And then we have a little bitty car who is also driving down the road at 20 miles per hour, right? We find out through calculation and whatnot that the mass times the speed is going to be directly related to kinetic energy, meaning that if you increase mass, you increase kinetic energy. If you increase speed, you increase kinetic energy. So basically, mass and speed, or mass and velocity, have an impact on kinetic energy. Now, how do we know? In this case, the bigger it is, the faster it's going, the more kinetic energy it has. And the way we can see that is by when it impacts with something. So when this truck hits something, it's going to have much more energy and cause that much more damage. So if we're talking on a small scale, like molecularly, then we have to kind of kick over to chemistry, right? And if we go over to chemistry, chemistry starts to talk about kinetic energy, and they bring in the kinetic theory of matter. And in that, they say that basically that all matter is composed of particles in constant motion, right? And if those particles are in constant motion, then they're constantly moving and sliding past each other, then they basically do what I would have you do if you're in class, which is I would have you start doing the Miyagi, right? The Karate Kid, and you would do your hands like this, right? You would feel heat, right? Then if I tell you to do it faster, right, then you would feel more heat. So the more motion we get, the more friction we get. The more friction we get, the more heat we get, and then that lends itself to higher temperature, right? So in this kinetic theory of matter, in the KTM, right, it says that temperature is the average kinetic energy of all of the particles in a substance. So that means if you have any given substance, some of the particles may be moving faster than the temperature you measure, some may be moving slower than the temperature you measure, but on average, they're all moving at that temperature, right? And then we can equate that Kelvin temperature will equate to average kinetic energy, and that's where we came up with Kelvin. So absolute zero, which is just a fictitious number, equals no molecular motion, right? So there would be zero friction, which would be zero heat, which would be zero temperature, right? So temperature then becomes a measure of kinetic energy. So anything that I do to temperature, or to motion, I would also do to temperature. So let's look at it. If I were to increase the heat input, that is going to lead to higher motion, which means more friction, so that's more kinetic energy, which leads to higher temperatures, right? So it's basically a directly proportionate relationship, right? So if I decrease heat, right, then that is going to decrease kinetic energy, and that is going to decrease temp, right? So if you understand, if I'm applying heat to something, that should cause the particles to move faster, and then that should cause more Miyagi friction, which then causes more temperature, right? I could also change the size of the particles and all that, but we're not going to worry about that right now. What I'm more interested in is that speed of particles and the collisions and interactions that makes, that then causes friction and heat, right? So if you understand this, that kinetic energy is the energy of motion, that it can be measured in temperature, because temperature is going to measure heat, then you should be able to understand these things and then make some good predictions. So go back over to the lab, make your predictions about what the temperature is going to do in this lab, and then next week you'll get to see how horribly wrong you might have been.